Dear students, how are you all? Today we are going to discuss statistics. So from statistics, I'm going to solve who is more consistent. So I'm going to use one of the measure from statistics called coefficient of variation, isn't it? So this is the most suitable tool to find who is the more consistent player or who is the more consistent student, isn't it? So if you are going to check who is the consistent, so let us use the tool called coefficient of variation from statistics, isn't it? Very interesting problem. We can solve one problem using that tool, isn't it? Okay, before we are going to proceed the video, kindly subscribe and like the video, isn't it? Thank you. So let us choose the problem from the data of scores obtained by two players A and B. Find who is more consistent. So we are given both A and B 10 values, isn't it? So using these 10 values, we are going to find who is the more consistent player, isn't it? Okay, very good. The most suitable formulas for A and B: standard deviation sigma A and sigma B, square root of summation d1 squared by n minus summation d1 by n the whole square. Similarly for sigma B, instead of d1 substitute d2, isn't it? Okay, what about d and n? N is number of values from A and B, that's all. And d difference between the given value A and the mean value x bar or y bar, isn't it? Okay, now x bar. So let us choose. There are two formulas for x bar: summation xi by n when we have the individual type of data. Similarly for xb bar, the same formula summation xi by n, isn't it? Or we can substitute the a plus summation d1 by n, a plus summation d2 by n. Okay, more or less one are the same. So here a is assumed mean, and go to the coefficient of variation for both a and b is equal to standard deviation by mean into 100, sigma by x bar into 100. So these are the formulas we are going to apply. So now this is a required table. So using this table you can find the solution. Okay, so please remember what are the required tables. Number one, given x, then d1 is equal to x minus x bar, d1 squared, and then y, then d2 is equal to y minus y bar, last one d2 squared. So these are the required columns for to solve the problem, isn't it? So x and y, first fill it. So we are given the values, 10 values, both x and y, write it, or ab, okay, whatever may be, no problem. So the total of x and total of y will be 329 for x, 133 for y. And then go to uh, finding x bar y bar, isn't it? So don't fill second column, third column, and for fifth column, sixth column. Okay, so first we have to fill this one and this one, find the total for both, then go to find x bar and y bar, isn't it? So 329 by 10, 32.9, so approximately equal to 33. Similarly, y bar is equal to 133 by 10 is equal to 13.3, approximately equal to 13. And go to second and uh, rest of the columns, isn't it? So all the values subtracted by the mean x bar, that is 33, and then find the total, that is minus 1. Then square the values. So we are getting 211 is the total of d1 squared. Similarly, we are going to do the same rule, same thing in fifth and sixth columns. So d2 3 and d2 squared is 61. Now we move to find the first standard deviation for a. Square root of 211 by 10 minus 1 by 10 the whole square. So this is 21.1, 0.01. So minus, it will be 21.09, taking square root it will be 4.59 is the first standard deviation. And go to the second standard deviation, that is sigma b, 61 by 10 and then minus of 3 by 10 the whole square. So 6.1 minus 0.3, 0.3 the whole square will be 0.09. So square root of 6.01 will be 2.45. So almost we got the values. Now we are going to using the formula coefficient of variation for both A and B. So 4.59 by 33 into 100. 4.59 is standard deviation of A, 33 the mean value for A. So multiply by 100 it will be 13.9. Second coefficient of variation, that is B, 2.45 by 13 into 100, 18.88. So from these two coefficient of variations, which is the least one? 13.9 is the least one. So that conclusion is player A is more consistent than player B. Okay, are you clear, students? Thank you so much. If you have any doubt, put it in the chat box. Thank you, Ananda.